Welcome back to Longevity Examiner. Today, we're delving into the groundbreaking insights from Dr. David Sinclair's book, Lifespan: Why We Age and Why We Don't Have to. Dr. Sinclair, a luminary in the genetics of aging from Harvard, presents a striking new perspective. Aging, he suggests, isn't an inevitable process. Rather, it's akin to a disease, one that can be treated. At the heart of this discussion lies the paradigm shift in our understanding of aging. So strap in and prepare to challenge everything you thought you knew about aging. At the heart of Sinclair's argument is the information theory of aging. It's an intriguing perspective that challenges conventional wisdom about the aging process. Rather than viewing aging as an inevitable set-in-stone process, Sinclair proposes that it's more akin to a disease, a condition that can be treated and potentially even reversed. The information theory of aging centers on the idea that aging stems from a loss of information within our cells. Now, this doesn't mean that our DNA, the blueprint of life, gets lost or damaged over time. Instead, it remains largely intact throughout our lives. The real culprit, according to Sinclair, is the epigenome. Think of the epigenome as a conductor, guiding the symphony of our genes. It instructs our DNA, telling it what to do, when to do it, and where to do it. This intricate dynamic system of instructions is crucial for our cells' proper functioning. However, as we grow older, this conductor starts to forget some of its instructions. It's like a well-played vinyl record that begins to wear out over time. The songs, or in our case, the genes, are still there, but the quality of the sound deteriorates. The epigenome gets disrupted, and the harmony of our genes is thrown off balance. This disruption doesn't occur overnight. It's a gradual process, a slow attrition that happens over years, even decades. But eventually, the accumulation of these disruptions becomes significant enough that we begin to notice the effects. And what are these effects? They are the signs and symptoms we commonly associate with aging: the wrinkles on our skin, the graying of our hair, the loss of muscle tone, even the decline in our cognitive abilities. All these can be traced back to the loss of information within our cells. In essence, Sinclair's information theory of aging provides a fresh lens through which we can understand the aging process. It shifts our focus from the symptoms to the root cause, from the surface to the underlying mechanism. This disruption manifests as the symptoms we associate with aging. Scene script: Sinclair also delves into the 9 scientific hallmarks of aging. First, let's talk about genomic instability. This is when our DNA gets damaged and our cells can no longer repair it effectively. This can lead to mutations and cellular malfunction. Next is telomere attrition. Telomeres, the protective caps at the end of our DNA, start shortening as we age. When they become too short, our cells can no longer divide and become senescent or die. Third on the list is epigenetic alterations. Remember the epigenome? It's the system that instructs our DNA what to do. Over time, these instructions can become disrupted, leading to improper gene expression. The fourth hallmark is loss of proteostasis. Our bodies have a system for making sure proteins are correctly formed and properly folded. As we age, this system becomes less efficient, causing misfolded proteins to accumulate and disrupt cellular function. Fifth, we have deregulated nutrient sensing. Our cells have pathways for sensing nutrients and regulating metabolism. With age, these pathways can become less responsive, leading to metabolic disorders. Cellular senescence, our sixth hallmark, is when cells lose their ability to divide but don't die. They hang around, releasing substances that can harm nearby cells. Mitochondrial dysfunction is seventh on the list. Mitochondria are our cells' powerhouses, but with age, they can become less efficient, leading to a decrease in energy production. The eighth hallmark is altered intercellular communication. As we age, the communication between our cells can decline, leading to impaired tissue function. Finally, we have stem cell exhaustion. Our bodies rely on stem cells for repair and regeneration, but over time, our stem cell reserves deplete, affecting our body's ability to renew and repair tissues. But here's the exciting part. Each of these hallmarks is not just a signpost of aging. They are also potential intervention points. By understanding and targeting these hallmarks, we may be able to slow down or even reverse some aspects of aging. Each of these hallmarks offers potential intervention points. A significant focus of Sinclair's research is on sirtuins, proteins that are like the guardians of our cellular health. They're like the superheroes of our body's cells. Just as superheroes fight off the bad guys to keep the city safe, sirtuins work tirelessly to maintain the health and vitality of our cells. Now you might be wondering, what exactly do these sirtuins do? Well, they have quite a few important tasks. They repair damaged DNA, decrease inflammation, and regulate cellular energy. You can think of them as the body's handyman, firefighter, and energy manager all rolled into one. They're crucial for our longevity, keeping our cells youthful and functioning at their best. But here's where it gets really interesting. Certain molecules can actually activate these sirtuins. One such molecule is resveratrol, which is found in red wine. Now before you go pouring yourself another glass, let's understand what this means. Resveratrol mimics the effects of a good diet and exercise on our cells. It's like telling the sirtuins, hey, we're living a healthy lifestyle here. Keep up the good work. Another key molecule is NAD, which stands for nicotinamide adenine dinucleotide. NAD is vital for sirtuins to function. It's like the fuel that powers the sirtuins' superhero abilities. Without it, they can't do their job as effectively. The trouble is, as we age, our NAD levels naturally drop. This means our sirtuins have less fuel to work with, and our cellular health can start to decline. But don't despair just yet. There are compounds out there like NMN or nicotinamide mononucleotide that can boost our NAD levels. By increasing the amount of NAD in our cells, we're essentially giving our sirtuins more fuel. This rejuvenates our cells, helping them stay young and healthy. So there you have it, sirtuins, the superheroes of our cells, fighting off the effects of aging. And while we can't stop the clock entirely, with the help of molecules like resveratrol and NAD, we can certainly slow it down. As we age, NAD levels drop, but compounds like NMN can boost NAD, rejuvenating cells. Sinclair's vision is transformative. His perspective on aging is not just about adding more years to life, but more life to those years. He challenges the traditional approach to treating individual diseases. Instead, he proposes that we target their common cause, aging itself. Dr. Sinclair believes that aging is akin to a disease, one that can be treated, slowed, and perhaps even reversed. He suggests that by addressing aging at its root, we can delay or even prevent the onset of many diseases simultaneously. This revolutionary approach could lead to more effective treatments for conditions like heart disease, Alzheimer's, and even cancer. The core of this vision is the information theory of aging. Sinclair posits that aging is due to a loss of information within our cells. While our DNA remains largely intact, the epigenome, which instructs the DNA what to do, becomes disrupted over time. The symptoms we associate with aging are manifestations of this disruption. The implications of Sinclair's vision are profound. If we can find ways to protect the epigenome and restore lost information, we can potentially slow down the aging process and extend our health span. It's a vision of a world where 90-year-olds are as active and vibrant as their younger counterparts, where age is just a number, not a limitation. Sinclair's research provides a roadmap to this future. His work on sirtuins, proteins that guard our cellular health, and molecules like resveratrol and NAD that activate them, offers promising avenues for intervention. By boosting the activity of these proteins, we could rejuvenate our cells and extend our health span. In conclusion, Sinclair's vision is a call to action, urging us to rethink our approach to health, medicine, and the very nature of growing old. The science of longevity is blossoming, and we're privileged to witness and perhaps benefit from its transformative potential. Imagine a world where 90-year-olds are as active and vibrant as their younger counterparts, where age is just a number, not a limitation. This is the future Sinclair envisions, and it's a future well worth striving for. Lifespan is not just a book about aging, it's a call to action, urging us to rethink our approach to health, medicine, and the very nature of growing old. Dr. Sinclair's insights aren't just idle musings or daydreams about the future. They're the product of rigorous research grounded in the real world of genetics and biochemistry. The science of longevity, as presented by Sinclair, is a transformative force. It has the potential to change our lives, our societies, and our planet. It's not just about extending our lifespan, but about improving the quality of our lives, making our later years as vibrant and active as our early ones. It's about treating aging not as an inevitability, but as a condition that can be managed and mitigated. And this isn't just a conversation for scientists, doctors, or health enthusiasts, it's a conversation for all of us. Because we're all aging, we're all part of this story. We all have a stake in the quest for longevity, and we can all contribute to it. But to do that, we need to stay informed. We need to engage with the science, challenge our preconceptions, and embrace the possibilities. And that's where you, our viewers, come in. Your engagement, your curiosity, your willingness to explore new ideas and embrace new paradigms is what drives us forward. If the possibilities of a longer, healthier life intrigue you, Don't forget to like, share, and subscribe to Longevity Examiner for more enlightening content.